Hello everyone. Good morning to all. I hope you all are doing well, right?
Good morning, everyone. Good morning, Vishal.
Good morning. Okay, so let me start recording. Let me record to the cloud. All right. Let me open my document and we'll start. Meanwhile, anyone have any questions from the what we discussed about the basic fundamental of the SD-WAN? Anything? Please feel free to ask, right? Else I will definitely start. Just one more minute. Let me figure out my training document. Good morning, Imam. Who is watching on the YouTube? Okay, so that's thing. Okay, all good. Okay, so we are good. Let me know if you guys are able to see my screen. Is it visible?
Yeah, yes, coming, sir.
Okay, good. Let me start the lab as well. All right. So welcome you all in the session. And today we are going to start very fresh about the further discussion about the SD-WAN. Where we
Yes,
will
I have one question.
Yes, please start with a question. That's a good start. Yes, please go ahead first. We'll take questions.
Actually, my question is this topology of the lab. So, how can I do this topology manually?
Manually, you want to build manually this topology?
Yes. Actually, if in lab scenario, suppose if I want to do them manually, then it will be possible. Can I configure all the router, vManaged all the device manually?
So see, actually, you have to build this controller, right?
Yes.
Build, there is no problem. But you require the admin access to build this lab. So you have any custom lab requirement you want to build that? Because everything is going in this lab, no config is going to be there. Means entirely it's zero config. Means even this PC we need to assign IP. So this topology is just for the reference we are going to use for the entire scenario. And that's a huge topology. So whatever you want to do, that is possible because you require the controller. So even you are going to put this controller in this place, in your topology, it is going to look like the same structure. Only the design is going to be changed. You require the transport might be single or might be dual. So this controller need to be connected. Then you require to build the branches. So your topology is going to be might be changed, but end result is going to be same. Means you have to require the controller, you have to require the branch office location, you require a dual transport, you require the LAN. So that's already integrated, and that's my commitment. There is no conflict, right? So we'll start from zero. So you're going to understand why this LAN is connected, how this configuration is going to happen, how this basically router is going to be configured to make this LAN connectivity. So I'll make one phrase topology. Let me make you in front of you all. So
Vishal, this is Arun.
yes,
If I'm
Arun.
not wrong, actually, what he's saying is he needs to prepare the lab on his computer. I think so. I think he wants to build the lab in EVNG or some
Is
kind
it?
of topology. I think so. That is what I mean.
Yeah.
Uh,
Is it
Yes.
you
No.
want to build? Yes.
Yes.
You want to build in your lab, right? In your computer.
Yes.
Okay. Sorry, I misunderstood. Okay. So for that, first thing, you require the very high configuration. So let me explain. So everyone who is willing to build the lab, so let me give some idea how you can build the lab. Okay. So just go in the EVNG documentation. And why I'm showing, because you should take a reference. So you want to build EVNG lab, so you just have to go evng.net and you have to go in the documentations. After going documentation, you have to refer how to create image. Okay. So after that, you have to figure it out the Cisco SD-WAN.
Okay.
And here is Cisco SD-WAN, Viptela image set. So you have to understand first requirement. What is the minimum requirement? Means hardware requirement is going to be look like. So let's suppose you want to deploy one vBond, one vEdge router, one vSmart, one vManage. So this is just for might be you are going to require 3 devices for the controller. This is the vManage, this is the vSmart, and this is going to be vBond. So if I want to build that much devices in my controller, so what is the minimum requirement? So for that, you can see for vBond, I required one vCPU and I required 1 GB RAM. Okay. And for the vSmart, again, I required one vCPU and 1 GB RAM. And for vManage, we required 4 vCPU and 16 GB RAM. So you want to build this three, then you required minimum 18 GB RAM as per the documentation, and you required 6 vCPU. Means you require the CPU as a total 6. Sorry, vSmart required 2. So you required 7. So 4, 2, and 1. 7 vCPU plus you require 18 GB RAM. So this is just for the controller. Now you want to add multiple branch. If you want to add 5 sites or 4 sites, so required further, you can just refer. 4 means you just multiply into 4. So you required 4 vCPU plus you required 4 GB more RAM. So this is going to be 18 plus 4 is going to be 22 GB RAM plus you required 7 for 11 vCPU. This is as per documentation. But trust me, minimum, because you have to run router, you computer need also some memory and all. So minimum, you required 60 GB RAM. This is also less. I would say it's 128, but 60 GB RAM where you can, and you require minimum 2024 vCPU. That is going to work very perfectly for your lab. And then your hard disk might be the 500 GB. It's enough, or might be the 250 GB also enough. That much also you require. This basically you required as a minimum hardware requirement to just build your SD-WAN lab. So do you have
How
that?
much? How much RAM size?
RAM side minimum should be 64 GB.
Okay.
And also you make sure they have CPU almost 18 to 24 GB. vCPU also required. And 250 GB hard disk.
Okay. So if I did not configure the lab in my computer, so for practice purpose, EVNG lab can I do in this session
Yes,
after the
definitely.
session?
Yes. So once like we start this session and everyone enrolled, right? So you are going to get this kind of the lab, and you just have to log in this lab by using your username and password. You require just internet access. After that, you
Okay.
just have to log in, and this topology is going to be available for you.
Okay.
So let me show you.
Sir, can you share the link of that lab?
Yeah, definitely, Rohit, you are going to get that. Okay. Sorry, why it's not working. Just give me 1 minute. Let me show you. Hold on. I should open somewhere, or let me try. I believe this lab is open or what? Let me check. Why it's not opening? Okay, let me open another lab. Might be. So if I'm going to open this one, so see, this is the lab. Once you are going to get the topology. What I can do that, let's suppose for this batch. So I'll just clone this topology and let me rename it. So we are starting this batch in the February. So I'll make this Fab 2025. Gwinnett. Sorry. Let me just rename it. All right. So this is the lab, guys, for you. And trust me, in this lab, we do not have any configuration. This is the completely blank lab. If I open any of the devices, let's suppose I'm opening this router, you are not going to find any configurations. We just have to build this lab from day zero. Probably we'll do something today as well. So after building this lab, you are going to gain confidence how step by step I have to do my SD-WAN configuration. It's not in lab. Suppose you are going to get a chance, start working in the enterprise infrastructure, ISP infrastructure. So you are going to understand how my control plane is going to look like, how the actual deployment is going to happen, and how my controllers are going to integrate with my branch location. At the same time, you are also going to understand, let's suppose I have to do the migration from my legacy WAN to SD-WAN. So what is the step-by-step approach is going to be happen? So these all things you are going to understand in this entire session. So that's why this session, SD-WAN is zero to hero sessions. Whosoever is going to attend, they are going to get full confidence about the SD-WAN, and that is going to boost your career in your CV, right? So you can see in this lab, if I just open, this is the blank router, no configuration at all once it is going to boot up. And similarly, if I just go and open any vEdge router, might be the vManage router, so they are also going to be completely blank. There is no configurations. So you can just feel and see right now. Abhishek, can you mute?
Hello, Vishal.
Yes, may I know your name if you don't mind?
Hassan.
Hassan. Okay, let me put Hassan. Yeah, Hassan, go ahead, please.
Actually, I just want to know types of devices used in SD-WAN and what is their use.
Okay. I'll cover. Give me some time.
Actually, today I am new,
Mm-hmm.
so I don't have much idea about SD-WAN, but I want to learn SD-WAN.
Definitely, Hassan. So everyone here, you can see almost 20 participants. They all are new and they all are going to learn from scratch. So you are also going to get everything, what devices we're using, why devices we're using, and how the connectivity is going to happen, why basically we are going to use the SD-WAN. So all I'm going to explain the concept. So you're going to get. And
Okay.
definitely I'll take your
Okay.
question on priority, okay? Because you asked.
Sure.
Thank you. So you can see here, if I'm just log into any of devices, so if I just going to put the username and password, you can see this device is still doing the sync up. So it's not taking my username and password, but after some time you are going to get a pop-up. Your device is ready. After that, you are going to put your username and password, then it is going to work for you. Similarly, you can see this router, there is no configuration. It's asking for the configuration dialog. So we have to do the step-by-step configuration for this router. So this is the your topology, and your baby you have to explore and you have to do from the very scratch all the configuration, right? So let me show you something once device is going to be ready. So I'll just log in. I'll show you how basically they are going to ask for the configuration. So you can see this is showing system initialization is still in progress. So it is going to take a little bit time. Meanwhile, if I'm going to open this router ISP, it is also not configured from any configuration. So you can see this is my router, which is now ready for the work. So see, this system is ready. You can see the vEdge. So I'll explain what is the vEdge. But if I'm going to put username and password, the admin, it is going to ask change your password after first login. It's a mandatory stuff. So I'll just put some password here and I'll just re-enter the password. And you're going to see that the prompt is going to, so here is the router and you can see this is the default configuration. Likewise, Cisco router and switch. You have the very brand new switch and you want to just explore. So you are going to get default configuration. Similarly, in the SD-WAN, Viptela SD-WAN, or might be any kind of the Cisco SD-WAN, which has been renamed as the Catalyst SD-WAN. Those are having some default configuration. And also we understand line by line why the system configuration is there. Might be you're hearing first time or seeing first time. What are the user configuration? What is the logging configuration? What is the OMP configuration? What is the IPsec security configuration? And the most interesting part, we have seeing the VPN configuration, VPN 0, VPN 512. Why it is available in this particular device? What is the relevant of this SD-WAN solution? And rest of that, we have to do all configuration from scratch. And this router, you can see, we do not have any kind of the configuration. So this is the default topology guy. Okay. Are we good to start? Any question regarding the lab anyone have, or we are good to start as per our content? Give me thumbs up if you are ready to start.
Yes, Vishal. Yeah, I think you can go
Okay.
ahead.
Thank you. So let me back to my origin topology, which is fully configured. I want to just showcase during the sessions when I just explained the concept, but that is not going to use for your lab. So this is my old topology, which is running on the weekend batch. So if I go here, you are going to see this computer, and this computer will log in our vEdge router. A vEdge, that is a controller, not a router. And we'll see some graphical interface. On that graphical interface, we'll try to explain some relevant concept. So at least you are going to sync up what is the written in the document and why this particular concept is look like in the GUI format. Okay, so I will just go and put this IP. Probably it will take a little bit time because we just started the lab. So let me wait. So it's not reachable. It will reach after 10 minutes. Meanwhile, let me start the concept. All right. So welcome you all in the SD-WAN session. And we have to understand first terminologies of the SD-WAN. Before I can explain the terminologies, means we have to understand what is my vEdge concept here. What is my CH concept here? What is my vManage? What is my vBond? What is my vSmart? And why you are using this root CA? Why this particular PC? And what is the transport we are using, the public internet or might be the MPLS? And why we are using this firewall as well? So we have to understand this all concept before we can start doing any configuration in our production environment, means lab environment. That's acting as a production because we have to do a lot of testing here. Just 1 second. Let me open one of the PPT here. 1 more second. So we just have to refer the Cisco official documentation. I'll just brief something from the different documentation so you'll understand. All right. So very first thing is, we know, like we discuss, whosoever joined very first time, might be you missed that particular thing, benefits of the SD-WAN. So we recap later on also. That's not a big deal because theoretically you have to understand. So we'll discuss the benefits. I'll show you the real use case, how it is going to look like. But for time being, we have to understand how basically my old router was doing the communication before SD-WAN was there. And after SD-WAN, how my communication start happening in the modern network, right? So you might be seeing this router. This is my Cisco 7604 router, or might be the any ISR router, ASR router, CSR router. or might be we have the L3 switch. If I talk about any of the devices, they all have the similar kind of the working structure. If I'm saying the similar kind of working structure, that means they have the similar kind of the architecture, similar kind of the traffic processing capability, similar type of the management and control plane processing capabilities, because they are going to work as a closed box architecture. Closed box architecture, that means everything is going to happen within the box. Means if you have to take the routing decision, I will do here. If I have to manage the control plane, I have to do within the box. If I have to do something switching, let's suppose it's a L3 switch, then it is also going to happen within the box only. So that's the closed box architecture. And this is the like how old routers or might be the L3 switch work. And still it's working in our network because routers are still there for the any ISP connectivity, or my switch is also there for any kind of the core aggregations layer connectivity. Might we have the collapse core architecture, we have the 3-tier architecture, we have the 2-tier architecture. Just one question out of the box. Anyone know what is a 3-tier architecture, what is a 2-tier architecture, and what is a collapse core architecture? Anyone know about it? Might be you have done this in CCNP. 3-tier architecture,
Core
2-tier.
access manage, core management access, something like that. CDP.
All distribution and yeah, access.
No, let's talk for 3 and 2 and then collapse. What is 3-tier architecture?
Okay,
Anyone?
the 3-tier is core level, distribution
Okay.
level,
Okay,
access layer.
very nice. So this is just I'm showing the simple topology. So this is going to connect like CS and they have the connectivity like that. So this is the 3-tier architecture. And what is your 2-tier architecture?
It's a spine and leaf.
Okay.
I think you can eliminate distribution. So it will be a core and access.
Yeah. So basically there could be either core or might be distributions. So basically we are going to eliminate generally in core layer in the 2-tier architecture, the distribution and the access would be there, right? For the small, medium range of the LAN, then we are going to use that. And what is a collapse core? If something is going to ask in the interview, what is a collapse core architecture? Anyone? Collapse core architecture. It's simple. When I just club this distribution and core together, that's going to become the collapse core. Means technically it's a 2-tier architecture, but just name as a collapse core architecture. All right, guys, clear? If you want to understand more about this architecture, so you just have to go in CCNP in core. You have to learn because this is this is the latest design like concept where the people are talking about this architecture. Many customers deploying and leveraging this architecture concept. So being a network security engineer, you should know about it. It's your responsibility to understand how my network topology is going to be look like and how my network has been designed. Because any architect, any network designer, any consultant, when they design the network, they have to follow the standard practice. So if you are also going to become those kind of the architect designer, you want to get more than 50 lakh or 70 lakh salary, or might be 1 CR in the upcoming future, might be after 20 year or 15 year. So you should have the very basic fundamental great understanding. Then only it is possible to design or architect any network things. So now let's suppose I am using the router. So how this router is going to do the processing of any packet? Let's suppose I have something here. I have the one computer, right? This is the PC. This is the PC A, and this is my PC, that is PC B. Just think, generally we not connect PC with the routers, but I'm just drawing the topology to make concept to be clear. Just think this PC RJ45 connected with this particular cable, and this is connected with this cable. Now this PC have the IP address might be the 172.16.10.10/24. This having the IP 172.168.10.10/24. This is my two LAN segment which is connected to the two different LAN network. Now this PC want to communicate with this PC. So what is going to happen? In this communication, this PC is going to build one packet. And in this packet, they are going to put some information. The first is source IP address. The second is destination IP address. So what is my source IP address? Destination IP address. He want to communicate with this particular PC. So when the packet is going to build, so what is the first step? You guys tell me, in the normal routing scenario, the routing happen based on the source IP address or based on the destination IP address? Who's going to tell me? In the normal routing.
Based on the destination IP address.
Okay, very good, Kejanan. What else, guys? I'm just repeating the question. In normal scenario, are we doing the routing based on the source IP address, based on destination, or based on the both?
Both.
Okay, good.
Based on both.
Destination base.
Thank you, Anurag. What else? कितने लोगों को पता है क्लास के अंदर, अगर आपसे इंटरव्यू देने जाते हो, अगर ये क्वेश्चन, व्हाट दिस इज द बेसिक क्वेश्चन, यू गाइस हैव डन द CCN and CCNP, बट दिस इज द बेसिक क्वेश्चन गाइस, ट्रस्ट मी. हाउ यू गोइंग टू आंसर? अगर सपोज आप इंटरव्यू देने आए, मेरे को देने आए, मैं पूछ दिया कि भाई चलो एक पैकेट है आपके पास, यू हैव टू डू द राउटिंग, दिस इज गोइंग टू हैपन बेस्ड ऑन डेस्टिनेशन और सोर्स और बोथ, सो हाउ यू आर गोइंग टू आंसर? I have just few answer out of 20 people. I'm little bit surprised.
Yeah, based on source and destination both.
All right, so thank you.
Based
Dushant,
on
you
source.
want to based on the
Source.
source. Okay. So we have, yes, Siddharth, Siddhant, you want to say something? All right. So this is something you guys have to understand. The packet level understanding you must have to keep in your mind. See, understanding and doing configuration, the static routing, doing configuration for the dynamic routing, doing configuration for the any BGP MPLS, that's good thing. But at the end, right, you have to be very clear about the basics. You have to be very clear about the basics, means the how my packet is going through from one source to another destination. So in normal routing scenario, guys, routing always happen based on the destination IP address. It's never check the source. Have you guys used the GPS? Everyone use the GPS, right? Global positioning system, right? Or what we call GPS. This is same full form, if I'm not wrong. So GPS we use, right? GPS, if you have to travel from your home to airport, what do you put in destination? Do you put really source? Sometimes you do not require to put source. Source is going to take automatically, but you always put the destination. I want to go there in airport, and then it is going to give the best path how you're going to reach to destination. Once you reach to destination, you want to back to your home and you don't know the path, then you put your home address as a destination, and this is going to become your source. So this is how you traveling in the real time scenario to just make your travel smooth and best path you are going to get to reach one destination, another destination, means one source, another destination. Same thing is going to happen in the routing as well. Routing always check the destination IP, never check the source. So if he want to come, he will check what is my destination. This PC will check the destination. Now this PC, before sending the destination IP address, which address he will try to reach? Which address? Anyone tell me? Anyone tell me which address before sending the destination? Anyone I'm asking? Gateway. Very nice, Siddhant. I really appreciate the gateway address. You have to think, means PC doesn't have the destination IP address. They have the sorry, they have the one thing, they just know the gateway, and based on the gateway they will reach to the gateway. Then gateway is your L3 device, and this have the all routing information, how and where I have to reach, and that is your routing table. Make sense? So based on that routing table, finally you have to push your traffic from one location to another location. So now my PC check the what is my gateway. Gateway is this. So it is going to punt the packet on the gateway interface. After receiving this gateway interface, this particular module, which is packet is going to punt, that is known as the IO module. What is the IO module? That is the input output module, or you can just say ingress egress interface, input output interface. So this is just the module where the packet is going to reach in form of the any binary, and then after, this module doesn't have capability to switch the packet to this interface. This doesn't have the capability. So it need to consult their brain. It need to consult their brain. And what is my brain? This is my control plane unit is going to act as my brain. So that is a totally different unit. This is not IO module is a control plane unit. This my control plane unit is something. This is my control plane and this is the actual brain of the router. So, or might be the L3 switch. So he is going to consult my brain. Hey brain, can you tell me how can I reach to particular destination? Then brain is going to consult with their routing table. They have again two kind of table. One is the RIB, that is a routing information base. And another is the FIB, that is the forwarding info base. Now you guys tell me what is different with RIB and FIB? Who is going to tell me? What is different between RIB and FIB? Very basic thing. Again,
RIB will take the decision based on the routing, which routing, static routing, dynamic routing, or which routing is configured. And forwarding is like on the RIB base, we have the forwarding base like पैकेट कहाँ से आया है और वहीं पे पैकेट जाएगा, like that.
okay.
Basically, RIB maintains some routing tables. All the
Okay.
routing decisions has been done on RIB only, and further the forwarding is taken care by FIB.
Yeah, RIB is routing information base where it will have all the routing informations, includes the destinations, gateways, and the exit interfaces informations. And FIB is the thing where forward information base which makes the decision.
Okay, fair enough. Appreciate it. Anyone else? Madan, you want to say something? Ashu, yeah. Ashu, please go ahead.
Actually, forwarding information based table has all routing information, and RIB table just implement the routing on the basis of FIB.
Okay, good. Appreciated everyone. Pintu, Rahul, Nilesh, Mayur, Madan. Yep. Anyone else? I want to give your version.
And
Everyone
also
has-
FIB uses Cisco Express forwarding as well. And it contains the, if I'm not wrong, it's an egress informations like exit interfaces informations to make a decisions of a routing.
Good. All right. So guys, sorry, actually, why I'm asking these all questions? Because I want from day one, your base should be very solid because you are going to learn SD-WAN, okay? And if you're going to learn SD-WAN, you want to become the next generation routing engineer or next generation switching engineer, you should have some basic fundamental understanding because this is something they are going to build a solid base, and based on that you are going to understand further advanced concepts. So see, RIB, as many of you mentioned, that routing information base, and FIB is the forwarding information based. But if someone is going to give the real-time example so that you can quickly make them understand what does means RIB and what does FIB. So simply, RIB is something routing information base that is collection of all possible routing path, right? That is RIB. But FIB is collection of best path. Just one thing. What does mean? Let's suppose, take an example. Just think about, we have, hold on. So let me clear this screen so I can make more good example. Let's suppose this is one of the router, okay? This router is connecting with some EIGRP protocol. This interface is connected with the OSPF. This is connected with the BGP. We have to understand FIB and RIB, okay? Now I'm advertising this one. The same subnet 10.10, 10.10, 10.10. Now I have two table. This is my RIB and below one is FIB. Now you guys tell me which all route is going to be add in the RIB, which is going to add in the FIB. I just want to test your knowledge as well, because I just give one statement. Still, we have to understand deeper side about the RIB and FIB. Also, your voice is very low. Can you just speak a little bit louder? It's still very soft, very soft. I'm not able to hear you.
All route to be stored in the RIB.
All are going to be
Stored in the RIB.
okay. So yeah, Tenjo, you're talking. So means this all are going to be RIB, right? You're saying that, right?
Yes, yes.
Okay. So Tenjo is saying like this is going to be RIB, means this all means BGP route is going to be RIB, OSPF is going to be RIB, and EIGRP is going to be RIB. And who is going in the FIB, Tenjo? Which one? All or any single one?
Yeah.
This
Can I
is
speak, sir? Can I speak?
yes, yes, go ahead.
Yeah, in FIB only EIGRP will go because we have
I just
the
mentioned this is
less,
the eBGP, this is the OSPF, this is the EIGRP.
EIGRP will.
Why you selected EIGRP? Gajanan?
Because EIGRP have less AD value and
What is
it
what is
and
AD, what is AD value of EIGRP?
70,
No.
70, 90, 90, 90.
90, yes, 90. Okay. And what is AD value for the OSPF
110.
and eBGP?
20.
20.
So now you tell me which one. EIGRP have the multiple AD 90, 170, and 5. So just exclude this two. I'm just talking normal EIGRP. So now you tell me which one is going to better route.
Sorry, it's the eBGP will go.
Right? Makes sense. So basically, my FIB is going to only install best route. FIB is just collection of the best routes. RIB is collection of the all possible routes. So for same destination, RIB having the multiple routing protocols, they are learning the route. They are going to store all the route in the routing table, but FIB is going to install the base. So in this table, only this is going to be installed /24, which is learning via the eBGP. If this is going to be down, then which is going to be part of this FIB?
EIGRP.
EIGRP. If this is also done, then finally OSPF is going to be happen. So this is the concept of the, in layman language, FIB and RIB. So I hope you guys are going to remember for a long period of time. And you can just do your research also. But it's a basic concept. Just collection of the, one is the best route, one is the all possible route. Shall I move next? Everyone clear?
Yeah.
Okay, so I was talking when any device is going to hit to this interface and want to connect with this interface, this having the 170 subnet, this one is the 192 subnet. So this is going to punt on this interface. After punting on this interface, what is going to happen? He need to consult the brain. That is a control plane unit. After consulting the brain is going to instruct how you are going to reach to the another subnet. So routing table is going to give the best path after consulting the FIB table. So you can see this is the one unit and this is another unit. They do not have any kind of the interconnections. So how they are going to make the connectivity each other? So for that, you require some switch fabric, which is your back plane. And in this back plane, what is going to happen? When you are just going to insert this card, this module, they are going to make a full circuit. And when you are going to insert this one, this is also going to make the full circuit. Means they are going to build some chipset ASICs. So when the packet is going to here, how it is going to reach here? So basically it is go in the back plane, and after going in the back plane, it is coming to this particular brain. And this brain is further giving the instruction. Based on that, he is going to get instruction, and then your packet is going to be out. So this is how your decision is going to happen in the normal router, normal switch. Means within the box, you have your IO module, that is your data plane processing module. You have the brain, that is your control plane processing module, right? This for the control plane. And you have the switch fabric, which is just making them as a broker. So this information is going to come here, this is going to come here, then it is going to make the full circuit. And after that, they are going to communicate each other. So that's how your any closed box architecture is going to work. Is it clear to everyone? Just give me thumbs up about this architecture, because next one is like something crazy. That's the open box architecture. Means we are going to decouple this entire box into different set of the box. That's the decouple. Means we are going to just open this box architecture and we're going to make the SD-WAN solution. That we have to understand. Thank you so much, guys, for your thumbs up. All right. So let's understand the same scenario, how it is going to happen for the SD-WAN solution. Okay. So here, if I go on this slide, this is my SD-WAN architecture. Again, the same situation is going to happen. I required one PC. I required another PC. This is the PC A. This is the PC B. This one having again the same kind of the logic /24. This one having this one connectivity /24. Now this router is going to connect on this vEdge. This router is going to connect this vEdge. And again, the packet is going to form. You have the source IP address. We have the destination IP address. Source is going to be 172.16.10.10. Destination is going to be 192.168.10.10. Right? Makes sense? Then how the processing is going to happen? One thing you have to understand. In SD-WAN routers, whenever you're going to design SD-WAN router, we required the brainless router. Means the router we are going to use for the SD-WAN. Let's suppose this is the edge router, right? These have the IO module. That's why we connecting one port here, one port here. So this is my IO module. Okay. But this router doesn't have any brain. Means we make this router as a brainless. So in closed box architecture, the decision was taken via the ASICs after reaching to the brain. But in the SD-WAN, we do not have any brain. Then how the decision is going to be taken? So in that scenario, what is going to happen? Whatever router you are going to use for the SD-WAN, we remove the brain from their individual box and put all brain in the central location. Just for the example, I'm just drawing this all. But you have to understand similar concept. Means my router is completely brainless. Means he not able to perform the routing. Then how the routing is going to happen? When the same packet is going to punt on the interface, then how it is going to happen? There is a Cisco box router. This could be the vEdge, could be the CS. Then how the processing is going to happen? For that, my dear friend, they need to consult with the brain. And after consulting the brain is going to guide you how you can process the packet to this interface. That's the difference between the normal box and the Cisco SD-WAN box architecture. Till now, clear, everyone? Shall I move next?
Yes.
All right. Thanks, Tanjo. So further, how this architecture is going to be look like and why it is going to be brainless? Because this architecture based on the design, based on the concept, their main motive to just make sure every decision should have from centrally. Means if you want to do the routing, you have to do from central location. If you want to push policy, means you want to do some sort of the engineering, you have to do from the central location, and that is known as the controller. Sorry, let me rewrite it. Sorry for my bad writing. Let me rewrite. Sorry. Hold on, guys. So this is my brain. And this is known as a controller. This controller further, how they're going to connect means we have the router sitting in the remote location, controller sitting in the another remote location. Might be I'm in India, controller is in USA, UK, might be the Frankfurt, might be the Dubai, might be the Singapore. It could be any location. Then how they are going to communicate? Earlier in the closed box, we have the closed circuits who are just making the connectivity. So how they are connecting in the SD-WAN architecture? For that, we required again a switch fabric. You can see here, again a switch fabric is going to be required. But this time, this is not your hardware switch fabric. This is not your ASIC based switch fabric. This is not your something based on the chipset closed circuit. This is your ISP. ISP is the Internet Service Provider. This could be the MPLS. This could be your broadband. This could be your any kind of the LTE, 4G, 5G, or any other media of the transport. So what is going to happen? Your edge is going to connect with the ISP, and this ISP is going to give the connectivity with your brain. Okay. So that's why it's become a switch fabric. Means it is going to act similarly as a mediator what the closed box architecture was doing based on the ASIC chipset and your, whatever the closed circuit was there. And then your communication is going to happen. So whenever you're going to make the connection, it is going to consult the brain. Hey, brain, can you just tell me how can I reach to this particular destinations? And based on his instruction, he will come to know I need to switch the packet to particular this destination. Now might be you have the question, if that is my brain is located in remote location and it's going for the every time consultation, do you guys think it's the best solution or it's the worst solution? Might be it's the worst solution because we have to going to add the latency. Because first we have to consult to brain is going to instruction, then I'm going to reach my destination. It's like, what the hell is going on? It's not a good process. So trust me, before 2015, 14, internet was too weak. Means if I'm talking the weak means it was not reliable. If I remember correctly, when I was in college, I have to download some movie. It was taking like, if I want to download some 1 GB movie or 2 GB movie, it was taking almost 15 days, 2 weeks, 3 weeks to download. We're using the BitTorrent and all. That time internet was worse. But after 2014, 15, 16, the internet is superb. You can see in your home right now, you're getting the very high speed broadband circuits. You are downloading the 1 GB file within the few seconds. Because of that, this only become a possible. This SD-WAN become a successful. Else, there is no way around we can do that. If my internet is going to become again worse, there is no meaning of using the SD-WAN solution. So how basically this architecture work? Basically, you have one of the device which is going to act as a controller that basically known as the vSmart. I'm just going to cover what else functionality. This vSmart is purely for the routing. Means if you want to do any routing decision, this vSmart is going to do all routing decisions. And whenever any device want to communicate with another device, so routing is going to propagate it by the vSmart. And that's why your all decision is going to be manipulated based on the vSmart, that is a controller. And also, you can see this is the vSmart controller, and we are seeing the vManage NMS as well. So we'll discuss what is my vManage NMS later on, but you just think about routing is always happen via the controller. Without controller, you cannot do the routing. And that's known as the control plane element. So this is the control plane element who is responsible to again maintain the routing table, maintain the FIB and RIB. But you don't actually relate like FIB RIB is going to be there. There is no such table you're going to find. You're going to only find this FIB and RIB in the router, normal router, but SD-WAN you are not going to find unless you have the CSR router or ASR router. vEdge, you're not going to find that. Is it clear? Any question at this point, guys? Please let me know if you have any questions at this stage. I would appreciate if you have any question or everyone understand. If you understand, give me thumbs up. If you not understand, give the thumbs down or ask your questions. Please. I can see Dushant understand. What else? Tenju, your voice is very soft, man.
Sorry, it's my mic. I didn't understand.
You understand? Give thumbs up if you understand. Your voice is very soft. I'm not able to hear. Ansu is also understand. All right. Good. Good. Shall I move next?
Yes, please.
Okay. Good. Arun sir, you understand? Everything clear?
Yeah. Thanks. Yeah.
All right. Mayur, Nilesh, you guys? Vrishabh Patil? Bimlesh?
Hi, sir. Thank you, sir, for this description. I want to know one thing. It's a WAN infrastructure, right? Is it possible for enterprise network? Is it
Your voice
possible to that structure be? Hello, may I audible?
your voice is breaking in between. Yeah, just go
Hello,
ahead.
may I audible, sir?
Yes, audible. Audible. Go ahead, please. Go ahead.
Yeah. Is this possible for enterprise network for structure like we can create on our enterprise network?
So, see, Mayur, whatever we are going to discuss, this is just for the enterprise only. And same is going to use for ISP. So, architecture which is going to design more or less enterprise integration. ISP, they have the core and MPLS and all. So, we are not going to talk that much. But yes, definitely we are going to do the same concept, leverage the same concept. But the design and architecture is more or less for the enterprise only. Means the controller is going to be separate location. Even I'm going to use for the enterprise or ISP, right? Okay, so Mayur,
Okay. Thank you.
yeah, definitely I'll
Thank you,
cover.
sir.
Okay, we are talking about the enterprise only. You're going to get more understanding. Just wait for a while. Tenju is asking, please. I don't understand how routing different with the vSmart compared to normal route. Okay, I'll come back to you. Just give me 1 minute. Okay, let me move to the further. Now it's a very good question by Tenju. How the routing is going to make difference between normal router to the vSmart? We just have to understand. So let me back to my topology and I can show you on the live. So let me see if I can open. Let me just open my rack. We'll just go here, admin. Let me show you something live, interesting, so you will understand. Still, you guys have to understand the each and every component. So see, this is the vManage dashboard. Still, I'm assuming nobody's know what is the vManage dashboard. So just hold your thoughts. I'll explain from the very scratch. This is my vManage dashboard. And in this vManage dashboard, you can see some component is looking like as a vSmart, for which I was talking, right? So you can see this is a vSmart. We have the vManage router and we have the vBond and we have the vManage. So we have to discuss in very detail what is the vEdge, what is the vManage. But if I click on the vEdge router, you are going to find we have some vEdge router, that is 1, 2, 3, 4, 5, that all vEdge router are here. And still we not integrated our CEdge router. That's why it's not showing. So later we integrate the CEdge as well. It's still not configured. That's why we're not able to see that. But if I talk about the controller, that is a vSmart controller. And if I show you the how the configuration is going to look like, just real time from the GUI, you can see where the CLI as well. So this is my, hold on. Okay, so wait, it is going to work, but you can see here, I just click on the real time. Let me go here and devices, controller. This is my vSmart. So I want to see the configuration. So I just click on it and running configuration. So you're going to see some configuration or device. I'll show from the CLI as well. So you guys going to get how this controller is going to configure, and then we'll see that how my routing distance is going to happen from the vSmart for the any branch location. Now it's fine. So let me just quickly log in it. And let me open 2 branch location as well. And let me log into this as well. Okay. And if I'm going to this particular router, you can see this is the configuration of the vSmart. So still you guys don't know how this configuration is going to be read, how it is going to be configured. So just ignore it. But let me explain the logic. If I'm going to on the vSmart, so first thing you have to understand, we have the lot of kind of the routing table, means routing, like we have the EIGRP, we have the OSPF for dynamic, we have the BGP, we have the ISIS, right? This is for the IGP and EGP routing protocol. But in SD-WAN, we have the another routing protocol, that is the OMP. That is known as the Overlay Management Protocol. And it have 2 type of AD. If this route is going to inject by the vEdge, then this is the 250 AD value. If this is going to inject by the CS, then it is going to be 251 AD value. So this you have to remember. So if I'm going to configure anything from the vEdge, then my AD value is going to be 250. If I'm going to inject from the CS, so it is going to 251. So any route. So if you see on the vSmart how the routing is going to look like, show OMP peer. So you're going to find you are making the peering with the different router, like 3 router, 4 router, 5 router, 1 router, 2 router. And if you just want to see show IP route in tabular format, so you're going to find this route is connected, that is the underlay routing connectivity. But if you want to run this command, show OMP route in tabular format, you are going to get more routes in the table. See, that much routing is coming. So what is going to be happen when I just take a reference from this particular topology? Let's suppose any branch is connected with any LAN segment. Just think about this is connected with the LAN segment. They want to communicate to each other. We'll definitely discuss how the underlay is going to build, how the overlay is going to build, but they want to communicate. First, they have to make the peer with the vSmart, and they have to advertise the route to this vSmart. Means whatever the LAN subnet they have, they first have to tell to the vSmart. Then this vSmart is going to tell to another vEdge router. And if this is going to down, this routing is also going to be down. So if vSmart is there, then only you can do the routing. If vSmart is not there, you cannot do the routing. That's the in layman understanding. But there is another key concept when vSmart is down. then we can still keep the routing for a certain time of period. That is the cache routing is going to be there, and still we are going to communicate. But even that certain time of period is going to be expire, then entire topology is going to be dead. That we'll discuss later or state. What is a GRS state? So we'll discuss about that. But you think about initially, VS not have the capability to do routing decision by themselves. They always go to the vSmart, and vSmart always reflect the routing to the other VH router. And based on that routing, they will act how I can make the communication with this another VH router. Is it clear, Tenjo? So this is the difference between the normal router and the SD-WAN router about the routing. So there is no direct routing is going to be created in the router. They will must have to go in the vSmart. vSmart is going to act as a RR. That is the route reflector. You must be heard about the BGP. So this route reflector is going to be always exchange. Means any branch, this branch want to talk. Let me use. If this branch want to talk, this branch, he cannot direct. He doesn't have the router. He first will get the routing from this. And after getting routing, he will come to know how to I can reach to particular this branch location. So this is how it is going to happen. Shall I move next? You understand about the controller, everyone? Okay, so let me do something about the more deep dive. So further we have to understand about the component of the SD-WAN. So you see here in this SD-WAN, just give me one more minute. This is my traditional WAN, which I was discussed earlier. In this traditional WAN, every router having their management plane, control plane, and data plane, and they are in the closed box architecture. So we decouple this architecture and we make as a open box architecture, and that's the SD-WAN. So if there is a closed box architecture, one router want to talk, he himself need to take a decision, and then he need to reach to another router. Then it's the third router. That's the fourth router. This is how it is. Traffic is going to follow to just make the entire series of the communication. But in SD-WAN, it is not going to happen. This SD-WAN, we have different planes. So one thing I explain here, we have the data plane where we are going to integrate my vEdge router or might be the CH router. So this is the routers. This is going to place at the data plane location. And once we place the router, they need to bring the routing connectivity to the control plane. That is my control plane device. This is known as the vSmart. So vSmart is something which is just used for the all routing manipulation, routing decision, which is going to happen from the vSmart router only. So this two device role we understand. Why use the data plane? Data plane is something where we connect the LAN. Means actual traffic is going to be inject. Control plane is something where we are going to get some routing decisions or best route connectivity. Now, what is my management plane and what is my orchestration plane and what is the vBond and what is the vManage? Why we use these devices? So basically, whenever you're going to talk in SD-WAN, you always keep in your mind, you have to remember Mr. James Bond, which is the vBond, Mr. Manager, which is the vManage, okay, and Mr. Smart, which is the vSmart, and rest are the employee, that is the either vEdge or CH. So why vEdge, why CH? I'll discuss. But let's understand what is a vManage. vManage is a device which is the single pane of glass. Means let's suppose you want to perform any activity for your network. What activity? Let's suppose you want to do the routing configuration. This config you cannot do here. It is managing the routing, but configuration is always done by the vManage. You want to do any router configuration, means like you want to create the ACL, you want to create some kind of the BGP configuration, you want to create some kind of the static route configuration, SNMP, NTP, any router configuration, that all is going to happen via the vManage. If you want to do any troubleshooting, that is going to be happen from the vManage. You want to export some link detail, that is going to happen from the vManage. So vManage is something that is the management plane device. This is going to be used for manage all your fabric, doing configuration, all your fabric, doing troubleshooting for all your network devices, which is belong to the hardware, and also you can bring the reportings. This can be single tenant and the multi-tenant. What does mean single tenant? What does it mean multi-tenant? Anyone know about it? What is single tenant? What is a multi-tenant? Any idea, guys? What does mean single tenant and multi-tenant? No idea?
No.
Okay.
Single tenant basically refers where only single customer is being managed, and multi-tenant where more than one.
Very nice. Okay, so see, single tenant means, let's suppose you are going to, there is just one example. There is one paying guest, right? Might be shared flat, you just think about. This is the one flat, right? And this is my, or might be just one single bedroom, right? Or might be the PG house. So this can be owned by the single person or can be owned by the multiple person. If it is going to own by a single person, the monthly rent would be, might be the 200 USD, right? He need to pay per month. But if it is going to own by the 3 people, right? Or might be the 2 people. So the rent could be, it is going to be 110 USD each, right? So you see here, the tenant also who is going to stay in this particular house or building or might be the single room, they also get benefited because they have the lower rent. The owner also going to get benefited because they are going to get 220 USD rent because they have to give the extra services. My water consumption is going to be higher, electricity is going to be higher, some other services, parking is going to be cost because earlier one person was there, so less parking was there, less water utilization was there. So there is a multiple factors going to happen, but end of the day he is also getting more money and they are also paying the less money. But what is the difference? So basic difference is like this resource is going to share by the 2 person. Earlier it was just shared by a single person. So security was high, the freedom was high. You don't have to worry about anything, like any mishappening is not going to happen, any thefts is not going to happen. So everything is going to be very like secure or like belong to the personalized for you. But if you make the multi-solution, your cost is going to be very low, but still you have to compromise something about your privacy, security. Some you have to very cautious while doing any kind of the personal things. So this is the multi-tenant and single tenant. Means if I am going to use the same vManage for the multiple customers, so my resources are going to be distributed for customer A, customer B, and customer C. But if it is going to use for the single customer, then it is going to be just belong to the every resource a single customer. Similarly, you can think about the VRF router. We can have the global routing table, and this global routing table can be further separated by the multiple routing table by creating the VRF. So the same logic, right? We just create the resource segregation for different customers, different users, so that my cost is going to minimize and I don't have to purchase again more routers. So simple thing is going to happen in the multi-tenant, single tenant. So in vManage, we can utilize the entire vManage for the one customer, or might be we can just use for the multiple customers same vManage, but separate instance is going to be created. Now let's talk about the orchestration plane. Orchestration plane is something where your vBond is going to come in a picture. This is a very powerful device, guys. In fact, every device is powerful. But why vBond is so powerful? Because let's suppose you want to join the fabric. This fabric is always known as a zero trust fabric. See, zero trust. Why zero trust? Zero trust means, let's suppose I have the 5 family member, and we know that, right? He belonged to my family only, but he went outside and he coming again inside. And I know he's my brother, he my like sister, he's my mother, or might be some other my family member. When he come to my again door, I will ask some passcode, or might be I'll ask some identity. You have to prove, then only I will allow to enter in my home. Might be why I'm doing this, might be somebody's like it's time for the artificial intelligence. It could be any possibility going to happen. Someone is just going to change your face, someone is just going to manipulate entire body structure. It's not possible, but just think about, in technology it's everything possible, right? So before trusting anyone, you just have to ask, prove your identity. If he or she fail to prove your identity, you are not going to allow to enter your inside of house. Simple as zero trust model. Means even user is going to access any applications like Citrix, FTP. If you're going to process via the network transitions, if you have the proxy and firewalls or SD-WAN solutions, they will first ask, just prove your identity, then I'm only going to allow the applications. If you fail to prove the identity, I will not allow the application access to you. So the authentication must be happen, posture management must be happen, device, every like posture means antivirus, virus means what is the compliance policy it is going to require, regulatory is going to require, that all must be checked, then only it is going to be allowed and it is going to be accessible to the any kind of the ISP or might be the any applications. Similar in the SD-WAN, let's suppose if I want to introduce any network devices, let's suppose I want to build any new router, that's a vEdge router or CH router, who want to join the fabric, who want to become a part of your organization and want to do the communication to the another router, before he can join and start doing discussion with the any devices, he must be proof the identity to the vSmart. So it is going to act as a HR. Just think about, you're going to get an offer letter from your company, right? HR and your hiring manager know that you are the same person who basically give the interview, you clear the interview. They know they have the very good picture, video recording of your interview. But still, when you are going to be join the company, they will not allow to join the company unless and until your background verification is going to be completed. BGF must be clear and they will ask your identity, like you have the government identity, any national government identity and all. After doing all verification, they will only allow to enter inside the company. Same thing. If this router want to join, then vBond is like one device who is going to validate you. After doing the validations, they will basically ask you to just show some your credentials. After showing some credentials, it is going to check their own database, and after that, they will allow to join the fabric. Is it clear about the vBond? I'll discuss more about the role responsibility, but please let me know. Is it clear? What is the vBond? What is the vSmart? And what is the role? What is the vManage?
Yes, we should.
All right, thank you. So let's do the deep dive. Still, we'll take 15-20 minutes more, okay? Then we'll conclude the session. So just stay with me, okay? Because we have to do a little bit deep dive also. Now let me back to this particular PPT and go one by one. We'll discuss the data plane CH also in very detail. Let's understand one by one. So you understand now orchestration plane, which device is responsible, management plane, which device is responsible, control plane, which device is responsible, and data plane is the actual router. It could be the vEdge and CH router. It could be a physical router, it could be a virtual router. So we'll discuss later on how this is going to look like. But let's do the deep dive. So let's discuss about the vBond, because we are talking about the vBond in detail. So you can see in the write-up also, there are some definitions. I have some chat. Let me. All right, Gajanan, no problem, no problem. We'll take break from tomorrow onward. All right, thank you. So you can see here we have the orchestration plane, management plane.
क्यों पेस्ट कर रहा है यार?
Anurag, please mute yourself. So you can see here orchestration plane, that is also known as the management plane, right? And here basically you can see first point of the authentication means if any device want to join the fabric, they must be authenticated by the vBond. If vBond is failed to authenticate, it will not join the fabric. That's the first point of authentication is going to happen. That's my vBond. Also, when the device join the fabric, their informations like which device join, list of device information, that is going to distribute list of the vSmart and vManage, whatever it is available in your fabric, to all vEdge router. Means once any device join, they need to know who is my manager, who is my basically routing provider, that is a vSmart, and what other router they have in the network in fabric. So that's all information also going to be shared with that particular all devices. Also very important thing, guys, the vSmart is responsible to facilitate NAT traversals. Anyone know what is a NAT traversals? I'll discuss a little bit more, but just want to understand what is a NAT traversals. Anyone have heard about it? No? See, NAT traversal. Yeah, Mayur, you want to say something?
Yeah, it might be LAN to WAN communication.
No, no, no. So, do you know what is NAT?
Yeah, netting, that is we are using NAT for our enterprise network to WAN network communication.
So normal NAT is just you have to translate. Generally, we do private to public translation or public to private
Yes,
translation,
yes, yes,
right?
yes.
We
Network
use
as
the
a
NAT. So that's a plain NAT. But what is the NAT traversals, right? So NAT traversals, just giving the example. Let's suppose this is your router. This is your one router. And this is your customer router, C router, C01. This is connected with the ISP router, right? ISP R1. And this is your ISP link. Means just think about the Verizon. This Verizon further connected with the one router. That is your another C2 router. This is the public IP. This is the public IP. This is another public IP. But here you have the private IP address. And you have the requirement to build the IPsec tunnel between these two routers. So technically it is not possible because to build IPsec tunnel, you require the public IP address both sides. So to achieve this requirement, we need to use, because your public IP terminating here, so you just have to do the NAT traversals enable on this entire IPsec tunnel configuration. Then only it is going to build your end-to-end IPsec tunnel when we have the private to public IPsec terminations. So that we'll discuss later. But yes, this kind of if requirement we have. Basically in production, we are going to find such kind of a requirement where my vEdge is behind the NAT device. This is a NAT device. And still they want to build the IPsec tunnel with the another side which is not behind the NAT device. So in that situation, we have to make sure to enable the NAT. And for that NAT facilitations, information like gathering, that is going to done by the vBond. That is also act as the Stern server. So I'll discuss later. And also you can see they are going to be highly resilient. Highly resilient means if you have the two regions might be the APAC and US, so you require the vBond in one region, another vBond in another region, and so they are going to make the communications. So this is little bit deeper side about the vBonds. You should know about. I'll share this documentation so you can make the note as well. Why this vBond is required and why we call the orchestration plane means it is just going to automate, orchestrate, right, or might be the manage your all devices which is coming to the fabric. So single point of authentication and providing the NAT facilitation as well. If we talk about the vManage, guys, so vManage the single pane of glass. That's for day 0, day 1, day 2 operation. Why day 0, why day 1, why day 2 operations? Because if you want to build any SD-WAN fabric, the very first thing you require the vManage. Similarly, we'll do in our lab tomorrow. Everyone join on the time. So tomorrow we'll see how this step-by-step configuration is going to happen for the vManage, vBond, and vSmart. And based on that, we will understand how basically day 0 going means how day 0 configuration is going to be start. So day 0, day 1, and day 2 operation is going to be happen, and they are just going to enable multi-tenancy. You want to do that. Centralized provisioning means by sitting in the single vManage. See here, this is my vManage. I can do all the configuration. So I'm in the vManage. And here, if I want to build any configuration, I can do all the configuration. Like I can create a template, feature template, any BGP OSPF configuration. So probably you're not able to understand what is this, but let's suppose I want to create any NTP, OMP, you can see BGP, OSPF. So we can create that all configuration from the vManage. Okay. And what else? If you go centralized policy template, we can create policy template. So see, this is my policy template. Let me show. So if you want to get policy and template, security certificate, so this all is under the vSmart. Troubleshooting and monitoring. So if I want to do troubleshooting, you just have to go here. Let's suppose I want to do some troubleshooting for any router, any device. So I can do the troubleshooting as well. Monitoring means what is my link utilization, what is my top talker, what is my top application which is used by the any user. So that detail also we are going to find from this particular vManage. So it is going to take a little bit time. So that all provisioning and troubleshooting also we can do from this vManage. If I want to do any kind of software upgrade, that also we are going to do that. How the software is going to be upgraded, what is the step-by-step process doing the software upgradations, and also we can create the rollback access, means role-based access. L1, if I want to get credential, L2, I want to get credential, L3, we can enable any kind of the REST API. Like if I want to do configuration from the REST API, like Postman tool, any third-party API solution. So that is also doable from here. So let me show you why it's not responding. Just hold on. So if I go here, you will see. Yeah. So if I'm going here and if I go in the real time, so you are going to find the troubleshooting scenario. So you want to see the WAN throughput, top talkers, right? You are going to get here. If you're going to troubleshoot, you can do some troubleshooting as well. Like you want to do the ping, trace, health check, app route, control connection, that you can do that. You want to see event logs, that is also possible. So this is something about your this troubleshooting stuff. But if you want to do the software upgrade, we'll say later we'll do that. So you have the software repository. We can do the software image upgradations for the any devices I want to upgrade. So I just have to click and do the upgradation as well. If I want to do some kind of the role based, like I want to get the different kind of the credential creation, so that is also possible. Let me show you. So if you go for the user management, okay, so you see here you want to create for the any user, like I want to create for the L1 user, L2 user, so I can just add here. Just I'm showing, later we'll do the lab practice. So level 1, so I can just give the read-only access, so I can just add the user. So that is a role-based access is going to be created. So you just have to put the small L. It's not going to take the capital letter. So just wait. So you see, this is label 1 created. Similarly, I can create the label 1. So we'll do later on how it is going to happen. But I'm just showing so you can understand what is written and how we can do the REST API. Let's suppose I have the Postman tool. I want to do some kind of API call on this vManage. That also doable. We can do that. Highly resilient means we have the two cluster and you want to do some kind of the primary secondary failover. That is also possible. The vManage. Now we have the vSmart. That is the actual brain where the logical things is going to be happen. So you can see this is going to facilitate. This is going to facilitate discovery means anything you are going to do that. Fabric discovery in terms of the routing, that is the one device which is going to be used. It is also disseminate the control plane information between this. What is the control plane informations? Like what is my routing, basically one LAN to another LAN, how it is going to be reached, what is the T-lock, what is the next hop, that all is going to share by the one device versus another device by the vSmart. That is the between the vEdge. And also it is responsible to distribute the policies. So you see, we have the policy, that's the brain we have to configure. So we have the control policy, data policy. So similar in the previous batch, we have tested two policy till now, and there is no localized policy. So we have to create n number of policy. These policy information are going to be managed by the basically this is the vSmart router. And also it is going to dramatically reduce the control plane complexity because it's a very simple hub and spoke kind of the or route reflector kind of the control management device. So this is just going to reflect the information between one device and another device, and they are going to be highly resilient. So that is also a very good thing. And based on that, probably we can do a lot of kind of the manipulation of the routings. So this is the vSmart gauge. Now the last thing, that is the vEdge router. So in the Cisco SD-WAN configuration, you are going to find two type of router. One is the vEdge router and one is the cEdge router. So who is going to tell me what is different with vEdge router and cEdge router? Anyone who attended the previous session?
Basically, the routers are the virtual routers. But when we say CH, it's actual physical device.
Actually, vEdge as in both physical and virtual, where which have in Vectella OS, and cEdge as in both Vectella as well as iOS XR or XS versions.
Yes. Thank you. So yeah, absolutely right. So there is no right and wrong questions because you are learning for here. So I appreciate both answers. But yes, vEdge is basically Viptela router that was designed by the Viptela. Viptela was the company, and some engineer was working in the Cisco. They separated themselves and built another company, Viptela, and they designed a very good product. And later Viptela was acquired, means Cisco acquired Viptela, and all engineer also part of the Viptela. So because of that, vEdge is basically it could be the physical, and this could be the your like virtual device as well. So it's not like something only the physical or virtual. So let me show you. So this vEdge can be your physical device or can be your virtual device. So see, this is my vEdge. So this is the physical boxes. You can see this can be the physical boxes, and this is also physical boxes. But this vEdge can be even virtual. This can be deployed in the like in our case, we are all virtual devices. So if I go here, you can see these are the vEdge devices. vEdge 100, vEdge, these are the physical device. But if I go down, this is my vEdge cloud. This is my virtual device. Controller are always going to be virtual. Means whatever we have discussed till now, means vSmart, vBond, this cannot be a physical device. This will be always a virtual device. Okay. We do not have the physical device for the controller. vBond, vManage, vSmart, it's a virtual device. But vEdge can be physical or virtual. Is it clear? And this is the Viptela device. It was a company who developed this entire solution and later Cisco acquired it. So this is about the vEdge and vEdge cloud. Now, if I talk about the Cisco cEdge, so cEdge is a Cisco edge, right? cEdge is a Cisco edge. So after acquiring the company, Cisco start using the ASR router CSR router, ISR router, CT router, C router as a CS device. Means the customer who have already this kind of devices, they just have to upgrade the iOS. That is based on the iOS XE, and then after they can use the SD-WAN solution. So they don't have to purchase the box. So that those devices who just converted from the ISR, normal ASR and CSR as a iOS XE and start supporting the SD-WAN, that's known as the CH router. Clear? Clear, everyone? So that's why you can see here, this CH can be even virtual, can be even physical. So if you're using the ASR router, they are all like physical box, but even you have the CSR 1000V, 8000. So in our case, we are using this CH. So this is my virtual router. So this can be either virtual or this can be either physical. So this is how it is going to be look like. So you guys understand something today? You get some value from my side or totally worthless? Just put your thumbs up or thumbs down so I can understand. So I'll try to add something new tomorrow. Thank you guys. Thank you so much for your support. I really appreciate. So now it's time for you. If you have any question, please ask. Else we need to bind up this session for today because a lot of theory I gave up to you all. You need to digest as well. So tomorrow we'll start with some practical. Okay. So if you're not already enrolled, please try to enroll today itself. So tomorrow you don't miss anything. And tomorrow we'll do the step-by-step onboarding process of devices. Means we are going to do the configuration from zero. This is the this is the old lab. So I'm not going to use this one. Let me go in the our lab. So we are going to use this lab. I just created for you all. So for this, we'll do the very zero level of the configuration from PC and this all devices. So we'll do tomorrow. So don't miss class. Same time it is going to happen. 10:30 IST. Okay, this is going to happen 10:30 IST to it is going to be 12:30 or 1 p.m. IST. Means 2.5 hour slot we have, right? And we'll try to finish. Okay, clear everyone?
हमको एक्सेस कब मिलने वाला है सर लैब का?
मिल जाएगा, कल मिल जाएगा सबको, right? Because once we start the lab, so you'll going to get lab. Okay, don't worry for that.
I have a question.
Yes, yes. Please go ahead.
Okay, the vSmart is a route reflector. Means he's sharing the routing information from one device to another device, right? So if my vSmart is going to be down, so my whole network, whole traffic will be dead.
Yes,
Okay.
technically yes.
Yes. Yeah, it's maybe the grace restart, the timer it's to be then the traffic would be flow at that time. But after the the grace restart timer has been completed, then my whole network is going to be down technically. So can you use the 2-3 vSmart?
Yes,
Then
yes,
my
technically,
traffic is
technically that's a resiliency. So we have the two regions, right? So might be the one vManage here, vSmart here, vManage here, and vBond here. So let's suppose this is connected this way. So if this is going to down, this is going to take in effect. So we can avoid the GR state. This is how actual network work. But we don't have that much big infra, so we have to learn here. But in production, you have to find the resiliency. The same step is going to happen, only the failover scenario need to be configured.
any device is available for to connect to vSmart or this directly connected to any other?
No, that's not required the connectivity. Just you required to build the overlay connectivity to this vSmart. Suppose this is my vSmart. There's another vSmart. He's also going to give the route. This is also going to give the route. Which one is going to install? This route. There is a selection process, right? I'll tell you how the routing is going to. So primarily he will install the routing from this one. Okay. But if he's going down, then he start learning route from there. That's all. Simple.
Okay, got it.
Simple. You have the two routers, right? One is down, then you start running from another router. Similar is going to happen. So you don't have to worry where vSmart is located. They don't have to be physical connectivity. They just need the logical connectivity. they will also make the sync up between each other. So I'll explain how this is going to be make the sync up as well. Tomorrow I'll explain, okay?
Okay, sure. Okay, thank you.
Thank you. All right. So wish you all the best, guys. See you tomorrow. Bye-bye.
Bye bye.